Hello, we're looking at TMUA 2016 paper 2, and this is question 10. And for this paper, this is the first time we've seen the word sufficient being used. So when we think about sufficient, to disprove something sufficient, all we need to do is find an example where it doesn't work. And then if we want to find out one where it does work, we should try and prove for all, in this case, X and Y. So all we're doing is trying to find X's and Y's that disprove these examples here. And if we can find them, then we can cross them off the list straight away. So X is less than Y. So for the first one, an example for the first one might be to try something where Y is negative. So if we have X equals 1, Y equals -2, then we can say straight away that X is not less than -Y. But what about the inequality? X to the power of 4 is still 1. 1, is it less than this to the power of 4? -2 to the power of 4 is 16, so that's not true. So A doesn't work, so we can say this is not sufficient. X is not less than Y for all X and Y's. Okay, for the second one, well, the second one is straightforward in the sense that we can just use positive numbers for this one. So use let's use X equals 1 and Y equals 2. Y equals 2. Then we have, this time we want to do it the other way around. So we get 16 is less than, is what we're trying to show. It's less than, and we've got 1. Again, that's not true. So that's disproved as well for all X and Y. For the third one, we want, well, this is just 1 over X is less than 1 over Y. So let's try, for this, let's try X equals 1, Y equals 2 again. We're getting 1 over 1 is less than 1 over 2. Again, 1 is not less than a half, so that's not true. That's disproved too. The next one, we can use negative numbers, I think. So if we put in X equals -1, Y equals -2, we get the, start with the Y's this time, so we get -1/2 is less than -1. Well, that's not true either. That's the wrong way around too. So the first four are not sufficient. Now the fifth one is much more interesting. This one here. This is X to the power of 3 over 5 is less than Y to the 3 over 5. Now what's interesting here is that both parts of the fractional index, they're both odd. So whatever you do with them will keep the signs. So it is safe, for example, to raise both sides to the power 5, because power X to the power 5 is an increasing function. It's always going up. The gradient is always positive. So you don't. So the inequality holds. So we can say that X to the power 3 over 5 to the power 5 is less than Y to the power 3 over 5 to the power 5. So simplifying that, we get X to the 5, X to the 3 rather, X to the 3 is less than Y to the power 3. And then same thing applies because X to the 1/3 is also increasing function. We can take the cube root of both sides and say X is less than Y. for all x and y. So a bit of a thought process going on to get to this point here, but it holds. So that's looking positive. And then we just need to think about the last one. The last one, well, because we've just shown this one doesn't make any sense now. So f will not work. But you could always check it maybe with -1 and 1. If you put -1 in here for the x value and 1 for the y value, you can show that that doesn't work too. So the answer to this, question 10 here, is just E. That'll do for now.